My name is Jairasi JC Parmar and my ID is 22CS048. Today I talk about Intel 80286 microprocessor through this PPT. So let's begin. Intel 80286 microprocessor introduced in 1982, fifth generation of i86 family. Fastest clock speed than a previous versions, 12.5 MHz clock speed to 10 MHz clock speed. In this microprocessor, a 16-bit processor is like a 8086 microprocessor. In this 125K transistor and HMOS 3 technology, advanced memory management, multitasking ability, better pipeline method, 4 independent functional unit in internal architecture. Some salient features of 80286 microprocessor. So, high performance microprocessor with the memory management and protection. 80286 is the first member of the family of advanced microprocessor with built-in on-chip memory management and protection ability primarily designed for a multi-user multitasking system. This microprocessor available in 12.5 MHz, 10 MHz and 8 MHz clock frequencies. Bus and memory size of a 80286 microprocessor. So 80286 CPU with a 24-bit address bus is able to address 16 MB physical memory, 1 GB of virtual memory for each dice. As you can see in table, 8086 microprocessor have a data bus with a 16 and address bus with a 20 and the memory size is 1 M. As well as you can see 80286 microprocessor data bus with is 16, address bus with 24 and the memory size is 16 M. Intel 80286 has a two operating modes, two real addressing mode, protected virtual address mode. Real address mode 80286 is just a fast 8086 microprocessor up to 6 times faster. All memory management and protection mechanisms are disabled. 286 is an object core compatible with 8086. 80286 works with all of its memory management and protection compatibility with an advanced instruction set. 286 includes a special instruction to support operating system. For example, one instruction can end the current task, second save its states, third switch to a new task, fourth load its states, and fifth begin executing a new task. These are the architecture of for 80286 microprocessor. There are mainly four units: address unit, execution unit, bus unit, and instruction unit. There, as we talk about 4 unit of 8026 microprocessor, when 8086 microprocessor only two functional parts. So let's talk about the address unit. Address unit is a calculate the physical addresses of the instruction and the data that a CPU want to access. Address lines derived by this unit may be used to address different peripherals. Physical address computed by the address unit is handed over to the unit. Bus unit performs all memory and input output read and write operations. Take care of a communication between CPU and a coprocessor. Transmit the physical address over address bus A0 to A23. Prefetcher module in the bus unit performs this task of prefetching. Bus controller controls the prefetchable module. Fetch instructions are arranged in a 6-byte prefetch queue. Instruction unit receive arrange instruction from 6-byte prefetch queue. Instruction decoder decodes up to 3 prefetch instruction and lays them onto a decoding instruction queue. Output of the decoding circuit drives a control circuit in the execution unit. Execution unit. Execution unit executes the instruction received from the decoded instruction queue sequentially. Contains a register bank. Contains one additional special register called machine status word MSW register. Lower 4 bits are only used. ALU is the heart of execution unit, arithmetic logic unit. After execution, ALU sends the result either over data bus or back to the register bank. Now the 80286 CPU contains the same set of registers as in a 8086. The first 8 16-bit general purpose register, second 4 16-bit segment registers, status and control register, instruction pointer. Now graphical view of a 80286 register, as we can see in this image, the code segment section, data segment, stack segment selection, extra segment selection. Here status word, instruction pointer. This is a diagram of flag register. As we can see, D0 to D15, carry flag, party flag, auxiliary carry flag, zero flag, sign flag, overflow flag. IOPL. As we can talk about in previous diagram, one unit is IOPL, input output privilege level flags, bit D12 and D13. Our IOPL is used in a protected mode operation to select the privilege level for a input output device. IF is the current privilege level is a higher or more trusted than the IOPL. Input output execute without hindrance. If the IOPL is lower than the current privilege level, an interrupt occurs, causing execution to suspend. Note that IOPL of a 00 is the highest or more trusted, and IOPL 11 is the lowest or least trusted. Nested task flag, bit D14. When set, it indicates that one system task have invoked another through a call instruction as opposed to a jump for multitasking. This can be manipulated to our advantage. Machine status word consists of four flags. These are P, MP, EM, and TS. LMSW and SMSW instructions are available in the instruction set of 80286 to write and read the MSW in the real address mode. This is a we talk about in previous slide TS, EM, MP, P. So TS is task switch, EM is a processor extension emulator, MP is a monitor processor extension, P is a protection enable. P. Protection enable. Protection enable flags places the 80286 in protected mode if set. This can only be cleared by resetting the CPU. MP. Monitor processor extension. Flag allows wait instruction to generate a processor extension. EM. Emulate processor extension flag. If set causes a processor extension absent exception and the permits the emulation of processor extension by CPU. TS task switch. If set this flag indicates the next instruction, using extension will generate to exception 7, permitting the CPU test whether the current processor extension is for a current task. CLTS clear task switch flag. Instructor clear the task switch flag bit to a logic 0. LAR, the load SS writes instruction reads the segment descriptor and place a copy of the SS writes byte into a 16-bit register. LSL load segment limit. The load segment limit instruction loads a user specified register with a segment limit. Where verify for read access. Verify for read access instruction verifies the segment can be read. VRW. The verify for write access instruction is used to verify the segment can be written. ARPL. The adjust request privilege level instruction is used to test a selector so that the privilege level of the request selector is non-violated. Thank you.